So I designed an impact-resistant resin 3D printed orthosis for a colleague who recently had 5 screws inserted into his left little finger. His previous orthosis worked, but it caused discomfort, especially due to sharp edges, so we discussed running some comfort tests with 3D printing. Since he was only visiting for a few days, I had to act quickly. I used the SnugFit app on my iPhone, which utilizes the front camera and LiDAR sensor to capture a 3D scan of his hand as the foundation for a custom-made design. After checking the scan quality, I exported a mesh and imported it into Spentys orthotic and prosthetic design software. I placed anatomical landmarks to let the algorithm handle most of the work, allowing me to digitally separate the fused fingers and reposition them according to the doctor's recommendations. Then, I defined the offset with a brush, sketched the orthosis directly onto the scan, and defined the wall thickness with a slider. Once the file was finalized, I sent the job to the Formlabs Form 4L, a large format SLA printer with a build volume of 353mm by 196mm by 350mm in set. The printer automatically filled the resin tank, ran a debris check, and then started printing 4 orthoses in under 4 hours. While the SLA printer was running, I took the opportunity to prepare and start a second job on my SLS printer, the Formlabs Fuse 1 Plus 30 watts. Although the machine supports a variety of materials, I specifically chose TPU 90A powder to offer him a flexible version of the orthosis as an alternative. Now back to SLA. Once the print was complete, I cleaned the parts in the form wash using fresh IPA for 15 minutes to remove any uncured resin, allowed it to air dry, and then post-cured it under controlled conditions to ensure full mechanical strength and biocompatibility. After curing, the part was no longer tacky and the support structures could be easily removed. The material I used was biomade durable resin, a transparent, biocompatible 3D printing resin with a high impact, shatter, and abrasion resistance. Finally, I used a rotary tool to smooth out any support marks to ensure comfort. For quality control, I ran my finger along all surfaces that would come into contact with the skin to get haptic feedback and check for any irritation points. In part 2, I'll walk you through the post-processing steps for the SLS print and share the results of a hands-on comfort test comparing both materials. So if you're curious how the flexible version holds up in a real-world use, stay tuned.